Hello, welcome back. In this segment, I will introduce a few set operations that are necessary for reverse engineering. Oftentimes, when you do code analysis or binary reverse engineering or whatever, you deal with set operations knowingly or unknowingly. And I'm going to show you a few important set operations that you could easily implement with help of Linux command line tools. You don't have to even implement, you can just call those commands to answer set operation questions. Let's get straight into an example problem. Let's say I have a set of variable names that I got it from code. Yeah. Login, password token, log, JWT, admin, and so on. A lot of words that you could extract from code, for example. And your question now is a particular variable present in the set? And my question is, for example, is log part of the set? You could use grep to do that, right? If you do grep log, and then you specify the file name, yeah, it will show all lines that contain the string log. My intention is not to match partially, and I wanted to match the full line. You can use the -x option to match the entire line. As you can see here now, login is not shown, only log is shown because log is a separate line on its own. Okay, so this is how you could check whether a particular element is present or not. And if you wanted to have a count, if you add an additional C to the command line options, you would get the number of times that particular word occurred on the set. Okay, I used the term word. In this case, with the -x, the word has to be the entire line. Okay. And sometimes, let's say I'm going to create an artificial example here, right? Here is log, and I can have another thing called log XYZ. If you just search for the word log, you still get only one hit because we are matching the entire line. But if I don't have that X, right, you get 3 because it's matching against log, login, and then login XYZ. Okay, this is how you could check whether a particular element is present in a set or not. This is a set membership question. Okay. How about checking whether two sets are equal? Maybe you have a set of variable names or function names, or whatever, from version 1, and then you do the same for version 2, and you wanted to know whether there is any change between those two versions. How can you do that? You can easily answer such questions with the help of diff and sort. I'm going to show you an example. Let's say I have a set 1, just to make some arbitrary examples, right? Set of function names like foo, main, and then run. Okay, this is my set 1, and I'll just copy this to set 2. And as you can see, clearly these two sets are equal. How can I check it? They're equal more systematically. You could very well use diff, yeah, in a quiet mode just to show whether they are different or not. How do I do that? -q. The first file content, I have to sort it because diff will show difference line by line. If you wanted to ignore the order, you can sort it, sort the first set, and only select the unique elements. Why do you need unique elements? What if the set has duplicates? I mean, in mathematics, set should not have duplicates, but if you're extracting list of variable names or file names or function names, sometimes you have duplicates in the code. So that's the reason I put a unique to just filter out the duplicates. And then I'm going to do the same for the second set. You see, there is no output. That means in this case, there is no difference whatsoever. But let's introduce some difference, right? Let's go to the set 2, add an extra thing called terminate. Okay, now hopefully we will see some difference. Yeah, the files differ. It was able to tell us this is one file, right? This is the second file, and these two files are different. As you can see, they clearly mention this. Okay, so we do know files are different if there's an output. If there's no output, we know files are same. Okay, so we can easily check whether two sets are equal or not by just using sort, unique, and diff. All right. Now I'm going to show you the third operation. How do you check whether one set is a subset of another? Okay, let's do that quickly. Remember, set 1 is foo main run. Set 2 is foo main run terminate. Clearly, set 1 is a subset of set 2. How can I check that? I can use the comm command, Unix command line utility called comm, which compares two files, and we can suppress some of the lines and get to know whether one file is a subset of another file. Let me create the first file, right? This is the first file is set 1, sorted, unique, sort set 2 unique. That means only unique lines will be shown. Let's see what happens. Comm shows 3 columns. You don't see 3 columns explicitly, but I will just decorate it for you. This is first column, which is empty. This is second column, which has only terminate, and then the third column. Okay. Let me tell you why the first column is empty. Because every element of the set 1 is present in set 2. That's the reason why the first column is empty. The second column shows elements that are present only in set 2. Okay. Clearly, terminate was the only element present in set 2. The third column shows elements that are present in both files. Okay. More precisely, both sets, which is clearly foo, main, and run. All right. So we can use Comm to extract set difference, set intersection. Let me show you now how I can use this to do a subset testing, right? If every element of set 1 is present in set 2, what are we expecting the first column to be? The first column to be empty. And that means we don't need the second and third column, so we can suppress that. Okay. And how can I suppress? Comm has this nice feature where you could specify suppress second column and third column. And now you have empty, which means everything present in the first set is present in the second set. Let us do one more thing. Suppose you would like to know intersection of 2 sets. How can I do that? You can very quickly use Comm. You need to suppress the first column and the second column because the third column is the one that shows everything that is present in both. You can see foo, main, run is present in both. So you got the answer for intersection by just using Comm. You also got an answer for subset by using Comm, because if the first column is empty, which was the case here, we can see first set is a subset of second set. Okay. And you can easily play with this Comm to figure out set complement also, right? If you suppress the second and third column, you would get every element present in the first, but not in the second. So you already get the complement. All right. With that, let us move on to union. How can I find the set union? In reverse engineering, you often do set operations, as I mentioned, and it's good to have a good understanding of set theory. Let us define union. Union means elements present in either one of the sets. Okay. So here is our set 1. Here is our set 2. And let us see if I do union of these 2 sets, right? How can I do union? You can use sort, and you could say sort set 1, set 2. But now you have duplicate. Foo is coming 2 times, main is coming 2 times. So you can select only unique. Now you have foo, main, run, terminate, which is perfectly fine. That's basically the union of 2 sets. So all you have to do is set. You have to use sort command with the -u option, and you specify the 2 sets. You get union of the 2 sets. Okay. Similarly, you can also do intersection with the sort, by the way. You could just say sort these 2 things, and now select the duplicates using the unique command. You see, as you can see, terminate disappeared because terminate was not present in set 1. Therefore, we can easily identify elements that are present in both using unique -d. Okay, this is how you could find intersection of 2 sets. Okay, you can also do symmetric difference between 2 sets just using sort and unique. I will leave that as an exercise for you. But essentially, diff, comm, sort, unique should be good enough to do a basic set operation among the 2 sets. Okay, that's all. Thank you very much for your attention.